Hey gang, today we're going to talk about enzymes. By the end of this lesson, you should be able to develop a cause and effect model for the specificity of enzymes. And don't worry about what that means. We're going to get into that as we go along. But first, let's start by talking about some enzyme characteristics. Okay? Okay? Enzymes are also known as catalysts. Okay, they're going to end in ASE. Now, remember when we had carbs, we said that carbs are going to end in OSE. So don't get them confused. If we see OSE, we're talking about a carb. If we see ASE, we're talking about an enzyme. Okay. Some examples include lactase and maltase. Okay. The ASC specifies that we are talking about an enzyme. They are substrate specific. Okay. Again, looking at our examples up here, we've got lactase and maltase. So lactase is going to be responsible for the breaking down of lactose. Maltase is going to be responsible for the breaking down of maltose. Okay. So they're substrate specific. That means that it can't just go to anything. I can't take maltose and use a lactase enzyme on it. Think about it in terms of a factory. Let's say you worked for Nissan or Ford Motors or whatever. Okay. The machine that makes brake pads is not going to be the same machine that makes oil filters. They're very specific. Enzymes are substrate specific and they are also reusable. After I'd have made my car part, I don't throw the machine away. I use the machine over and over and over again. Okay. Enzymes are the same way. It's a big machine that's either going to break stuff up, break stuff apart, or bring stuff together, and I'm going to use it time and time again. Now, enzymes represent a particular biomolecule. They're going to represent proteins. So whenever we talk about an example of a protein, enzymes is always a good choice. But remember, all enzymes are proteins, but not all proteins are enzymes. Okay. All of our enzymes are going to be classified as proteins, but just because we see a protein, that doesn't automatically mean that it's an enzyme. So, what exactly do enzymes do? Enzymes speed up a chemical reaction. Okay. When you think of speeding something up, you're making it go faster. So, with the addition of an enzyme, a chemical reaction that I'm performing is going to go a little faster. And how does it do that? By lowering the activation energy. If we thought about what activation energy means, it's going to mean the energy needed to make a reaction go. So every reaction has to have a certain amount of energy to run. Enzymes lower that amount of energy that is needed so the reaction can run faster. Okay? Let's look over here at our graphic. All right? What you see in the red is your reaction, and there is no enzyme present. Here is the activation energy. Once it reaches that amount of energy, now the reaction can go, and then eventually I end up with a product. Okay? But now look, when I introduce the enzyme here, notice how much less energy is needed. Now my reaction is going to go a little faster. I'm going to get to products a little faster. Now, what you see here is what's called the enzyme substrate complex, or you may see it referred to as the lock and key model. Okay. This is just kind of showing how your enzyme kind of works. So, first, I got to start with a substrate. Your substrate can also be known as a reactant. Okay. If you think about physical science or if you've taken chemistry, your reactant is usually what you need to make a reaction go. Okay. So, we got our substrate. Now, where the substrate and the enzyme meet, that little groove, this little groove you see here, that is called the active site. Nothing can happen until the substrate and the enzyme meet at that active site. The big purple glob, that's our enzyme. When the two come together, we call that the enzyme substrate complex. Then the outcome is the product. And notice how my product looks different from my substrate. Okay. I started with a single molecule. Now I have two individual molecules. So I have from my reactants, I created a product. And then my enzyme goes on ready to be used again. Now, there are ways to hurt an enzyme. There are ways to keep that factory or that machine from running perfectly. And we call that denaturation. Okay? By definition, that means the disruption and possible destruction of an enzyme or protein inhibiting. To inhibit something means to prevent, preventing protein function. Okay? We can denature an enzyme by changing the pH or by changing the temperature. And that temperature and pH is going to vary depending on the enzyme. So, what exactly happens? If we look here in normal conditions, you see that I got my puzzle piece and it's going to fit perfectly into my puzzle. That means I have the optimal pH or at least a conditioned pH, and I have an optimal or conditioned temperature. Okay? But what happens is that active site becomes damaged once I get outside that optimal pH or optimal temperature range. So once that active site is damaged, now I have prevented my substrate enzyme from attaching. Okay. So now look, I have an extreme condition. Look at my active site. Now my puzzle piece that's over here is not going to fit because the active site has been distorted and it's not going to fit together like a nice puzzle. So, in summary, enzymes are biological catalysts that are used to speed up chemical reactions by lowering the activation energy. You can see this is lowering the activation energy, decreasing the activation energy. All that means the same thing. Enzymes are substrate specific, meaning they're going to be for a specific piece. Like when you put together a puzzle, you just can't stick any piece anywhere, and are reusable. We're not wasting anything. We're going to reuse it till it breaks. Enzymes can be denatured by change in pH and temperature. When this happens, it alters the ability for the substrate to bond properly. Now you're going to go on and complete the enzyme practice assignment in the Bioman. And then once you've completed that activity, submit it to Canvas. If you have any questions, feel free to ask.